So we're going to take the derivative of this f of x function. Now to use the power rule, the question is, how do you use a power rule when there's no power? Well, what you do is you change this into a fractional power. You have to see this as a fractional power, then you can apply the power rule. So, do you understand there's a 1 hiding right there? And then hopefully you also understand this is f of x equals x to the 1/3. Because I always say the root is at the bottom of the fraction. Just like roots are at the bottom of plants, roots are at the bottom of the fraction, and that 1 goes on top. Now you can apply the power rule. So for the power rule, the power rule, what you would do, you put the prime, saying you're taking its derivative. You take the 1/3, you put it out front, and you drop the power by 1. Now, for some of you that's a little bit harder, so you get 1/3 minus 1. Oh, 1/3 minus 1, isn't that 1/3 minus 3 over 3? Which is negative 2/3. Now that is an answer, but you could also rewrite that in other formats. So that is an answer. But let's maybe, first of all, get rid of negative powers. So if I get rid of negative powers, another way to write this answer could be f prime x is equal to 1 over 3 x to the 2/3. Because don't negative powers go to the bottom? But could you also put the radical back on? Could I also write it as this? F of x equals 1 over 3 cube root of x squared. And there's plenty others. There's different ways to even write this. There's so many different ways to write it. You can write it different ways. Multiple choice could have it in different formats. They're all reasonable. So for this one, well, we do have a power rule, but it's on the bottom. And you can apply the power rule while it's on the bottom, because that's really a quotient. And there's a derivative property called the quotient rule coming up. So I can't do it when it's down here, but can I just move it up and make it a negative power? And then apply the power rule? So watch. What you can do here is you can rewrite that as 6x to the negative 3rd. Because you move the power up, make it negative. Now you can apply the power rule. So y prime is equal to 6 times negative 3 is negative 18. X to the, whoa, be careful here. A lot of people mess this up. Negative 3 minus 1 is not negative 2. Negative 3 minus 1 is negative 4. Be careful of that. It's a common mistake. People manage wrong. So just be careful. But from there, well, a lot of times we don't like negative powers, but you could. So let's change that around. That could also be y prime equals negative 18 over x to the 4th. They're both doable. So for this last one, you can't apply the power rule because this 4x is a quantity. This is a composite function. Now, later on, you'll learn something called a chain rule that allows you to do this. But can't you rewrite this as a power rule problem? And here's what I mean by that. What I want you to understand is this is really 4x times 4x times 4x, which isn't that really 64x to the 3rd? Oh, okay, easy power rule, if you just reconfigure it first. So now we apply the power rule. So g prime x is equal to, for this problem, we're going to do that one. So, 3 times 64, okay. That's not a quick and easy. So that's 192. Put 192 there, so it'll be 192 x to the, drop the power by 1, squared. Done. So to take the derivative of this, you can use something called the product rule, but we haven't learned it yet. So what we have to do is we have to change this to a polynomial. And the changes to a polynomial, what you basically want to do is you just are going to do this little mechanism. People call it FOIL. And change it to x squared plus 3x minus 4 when you multiply that all out. Then you apply the power rule. So f prime x, the first piece is going to be 2x. The second piece is going to be 3. And the last part, do I have to put minus nothing? Kind of pointless. And we're done. There it is. That's the derivative. So to do this derivative, Well, again, this isn't a quotient format. There is something called a quotient rule. You could take the derivative with that, but it's way easier to change this into this format. So to do that, what we're going to do here is we're going to take and divide each piece by the x. And then rewrite that by simplifying each. So there's a 1 here that might help some of you. When you do x to the 5th over x to the 1st, you subtract the powers, so that's x to the 4th. When you take 2x over x, you cancel out the x's, so that's just minus 2. And the last one, since I want it to be powers, can I rewrite the last one as negative 6x to the negative 1st? Bring it up, because I want it as a power so I can apply the power rule. When it's still on the bottom, I have another quotient I want to deal with. So right there, I can now deal with those 3 things. So we're in an okay spot. So y prime stands for derivative. The derivative of the first piece is going to be 4x cubed minus, well, the derivative of negative 2, isn't that 0? So I'm not going to put 0. That's kind of pointless. And for the last piece, be careful here. The negative 1 times the negative 6 is a positive 6. X, and when I take negative 1 minus 1, isn't that negative 2? Okay, so there's an answer, but most of the time we don't want negative powers. So let's reconfigure that as y prime equals 4x cubed plus 6 over x squared. Now, you can also do one more alteration, which will help you later on with derivatives. A lot of times you want to make it so there's not a non-fraction and a fraction added. You want to put them together into one fraction. So you could also do this format. Let's see if you can understand what the heck I just did. Let's see if you can figure it out, what I'm doing here. Can you see, hopefully, how I got that? Can you see I multiplied top and bottom here of x squared? So this can group into one fraction. So this format is very useful later on when we apply derivatives and stuff. So knowing this to this is huge. But just knowing how to find these two are most likely what your answer is going to look like.